So hello and welcome to our first video in this pre-calculus series. We're going to get started off here with something pretty general. The big idea of pre-calculus, which will kind of underlay or provide the foundation for the whole course, and which we'll talk about a bunch in future videos, is going to be the study of functions. We're going to step back just a little bit more broadly to see just a little bit more of the general picture in this first video here to talk about relations. Now, if this is your first pre-calculus class, it's probably not likely that you've heard this word before, and that's okay. Pretty much all we're going to do for this first video is define kind of what that is, and then define domain and range, which are terms you may have heard before. In the context of a relation. And this relation is sort of, again, it's like the general picture, a sort of abstraction of a function, if you will. And it's just gonna give us kind of that bigger, broader picture before we start to narrow in on the specifics. Now, if you're taking this pre-calculus course and you're coming from an algebra class, you may have some sense or some familiarity with the kind of big ideas of an algebra course, which is, it's really all about how two different quantities relate. So we construct and solve equations in an algebra class. You might even learn a little bit about how to write a function in an algebra class. And those things describe the relationships between quantities. You might be talking about a projectile being launched through the air and how its height varies over time, right? And we can write an equation that, models how high that object is going to be after some amount of time. And so we can relate the quantities of height off the ground versus time since some starting point. That's really one of the like underlying foundational ideas, is the relationship of two different quantities. Now, a relation, having that similar kind of root word, it's going to be really, really similar, just a little bit more generic, right? Like we said, we're kind of taking that step back here and seeing the bigger picture. And what that's going to mean in our case specifically is, rather than relating two quantities specifically, things that are numeric in nature, quantifiable, this can be just relating any two objects. So any two things that we can pair together, that's gonna be what constitutes a relation. And so we can actually define this a little bit more specifically here. We'll get our definition of a relation. Really simply, a relation is really just any set of pairs. Any set, and we'll be a little bit more specific here to say any set of ordered pairs. Now, ordered pairs you might be familiar with already. Right? We use ordered pairs x comma y to represent different coordinate points on a Cartesian coordinate plane, right? So like the horizontal axis here is all the x values, and then the vertical axis here is all the y values. And if we have a coordinate of 10, 5, that means we're going 10 steps to the right and 5 steps up along this coordinate plane. And that's really all that means. So you could see something like 10, 5, and that's going to be 10 steps over this way, 5 steps up this way, and maybe that looks something like this. And so if we had a whole set of these, that would define a relation. But this can be even broader than that. It doesn't even have to be numeric in this case. So for example, the Olympics was this past summer, and you may have watched your favorite swimmers or runners or gymnasts or whatever the case may be win a bunch of medals for varying countries. And so if we actually go here and look at, I just pulled this up from sportingnews.com, but we can look at the Olympic medals per country. And we can actually form a relation where the first coordinate of the ordered pair, the first component of the ordered pair is just the country's name, and then the second component of the ordered pair is the number of medals. And so for instance, if we were to look at this, we could form a relation. So an example of a relation would be a collection of all these ordered pairs. So for example, the United States, comma, 113, because the United States won 113 medals. Or China, 88, because China won 88 medals, right? And this relation represents the relationship between the country and the number of medals they won. And we could keep this going, right? We could say Japan won 58 medals, and so on and so forth, right? And we could extend this out further and further for all the countries that participated in the Olympic Games if we wanted. You'll notice a few things here. When we write, so when writing ordered pairs, and writing ordered pairs, we use parentheses and a comma between the two components, and then we use brackets around a relation, And so what we'll do here to make this correct notation is we'll put brackets around this and put commas in between the ordered pairs. And so this will represent a relation, right? In this case, it represents the relation between the country and the number of medals they won at the Olympic Games. And so, as you can see, and as you can probably imagine, there is a whole infinite number of ways in which we could set up a relation. It really just comes down to any set of ordered pairs. Now, being an ordered pair, we can define domain and range. You may be familiar with this already, right? If you've taken an algebra class before, the idea of domain and range may be somewhat familiar already. You may have thought in the past of this as something like the set of x values and the set of y values, right? So you might have said, well, the domain is just the set of x values. I'll put this in quotes, the set of x values, and the range is the set of y values. And this is a great way to think about it when we're working with algebraic equations, right? And we can graph those on a plane, and there's some certain x values and some certain x coordinates, and then some certain y values for some certain y coordinates. And so this works really well when thinking in that context. Domain and range, though, are actually a little bit more broad than that. And because they're a little bit more broad than that, we can apply them to a relation. And so what we'll actually say here is, rather than just specifically saying x values, because these could be x values, they could be numeric, or they could be like a country, we'll just define them specifically as the first coordinate of the relation. So whatever that ends up being, that first component is going to be the domain, or all of the stuff that makes up the first components is going to be the domain. And so we'll say the set of all first coordinates or first components. I should really say components. Coordinates is specific to the graph. But the set of all first components of the ordered pairs of a relation is called the domain. And likewise, not just the y values, but all of the second components is going to be called the range. And so the set of all second components of the ordered pairs of a relation is called the range. So the first components represent the domain. That's like the x values in the specific case of an equation that we're going to graph. The set of all second components, which is the y values in the specific case of an equation we're going to graph, is called the range. And so let's look at an example. We want to find the domain and range of the following relation, right? This is one of our key objectives. Can we identify the domain? Can we identify the range? And so we've got a collection here of 1, 2, 3, 4, 5 ordered pairs, each with a first component and a second component. And so we have to identify what makes up the domain and what makes up the range. Now, if we remember here that the domain is the first component of these, we're going to be looking at USA, China, Japan, Great Britain, and ROC, right? The first ordered pair, or the first component of these ordered pairs as listed here in this relation. And so we can say, as our solution here, the domain is the set of values USA, China, Japan, Great Britain, and ROC. And I'm gonna write them this way on purpose, right? You'll notice here that I've got those same squiggly brackets on the outside of this. That's again just because that's the notation that we will use for sets. And because a domain is the set of all first components, we're gonna use that notation here and just separate each of the elements by commas. And so this would be the way that we could write that out best. Now the range, similarly, we know the range from what we just learned is going to be the set of all second components. And so what we're looking at here is the 113, the 88, the 58, the 65, and the 71. And so all of those together as a set represent the range. And so we can write our solution here. The range is the set of 113, 88, 58, 65, and 71. Right, and these here would represent our final answer then. The set that's the domain, USA, China, Japan, Great Britain, and ROC, and the set that's the range, 113, 88, 58, 65, and 71. I hope you found this video helpful. In the next video, we're gonna hone this in a little bit more specifically to talk about functions, which is kind of really gonna be the main topic of a pre-calculus course. I think pre-calculus in the name itself, right? You think like preparation for calculus or the thing that needs to come before calculus, and that's all true. But I think kind of a secondary name that would work really well is just simply the study of functions, because that's really what we're gonna get into a lot over the course of this semester. And so I will see you in the next video where we talk a little bit more about functions. Until then, I hope you have a great rest of your day.